here on the board we have the pitcher throws the batter, or throws the ball to the batter. So the pitcher throws the ball to the batter like so. Then the batter hits the ball to the shortstop like so. Assuming the ball travels in a straight line between each, what's the total distance traveled by the ball? So I need to find the blue distance from the pitcher to the batter, and then the red distance from the batter to the shortstop. In each case, we're looking at a distance between 2 points in a diagonal line. So we're going to have to use the distance formula to do that. So if you take a look at the graph paper here, it says 1 unit equals 9 feet. Okay, so the numbers we have on the picture don't represent how far it actually goes. It represents, like from here to here is 9 feet, from here to here is 9 feet, 9 feet, 9 feet, 9 feet, and so on. I'm going to find an answer in units and then take my final answer times 9. Does that work for everybody? Can we handle that? So, if I'm looking at the pitcher's position in units, it's 5 right and 5 up, so the pitcher's position is 5, 5. The batter's position is 0, 0. So the number of units from the batter to from the pitcher to the batter, if I use the distance formula, we'll say distance from pitcher to batter, PB for pitcher batter. Now I'm using the distance formula here, just like the last problem. So I'm going to create the structure of the formula. What goes in the first parentheses is the horizontal direct distance from one to the other. So if I'm at the pitcher's spot at 5, the x-coordinate being 5, getting to the batter's x-coordinate of 0, how far did I go? 5. If I'm at the pitcher's y-coordinate of 5, end up at the batter's y-coordinate of 0, how far does the ball go? 5. So again, I got a horizontal and I have a vertical direction. It goes 5 horizontal, 5 vertical to get from batter to pitcher. Okay, so the distance from the pitcher to the batter is equal to the square root of 25 plus 25, which equals the square root of 50. Okay, it says nearest tenth of a foot, so I'm going to round everything to the 100th of a foot before I multiply by 9. Just get a round answer here. So, oops. All right, calculator up. So if I type in the square root of 50 square root, it's going to be 7.07. Now the pitch comes to the batter, and the batter swings and hits it to the shortstop, also on a straight line. The path the ball is traveling here starts at 0, 0, and it ends up here at the shortstop. When we look at the coordinates of the shortstop, we're going 5 right and 10 up. So 5, 10 is the position of the shortstop. So now I'm looking for the distance from the pitcher to the, from the batter to the shortstop. So distance from batter to shortstop is going to be the square root of parentheses squared plus parentheses squared. Again, anytime I'm doing distance formula, find the length of a segment, I want to create that structure every time. In this first parentheses, I'm looking for how far did x change. I started at x equals 0, I ended at x equals 5, so it changed by 5. Then I'm looking for how much does y change. It starts at y equals 0, ends at y equals 10. That's a change of 10. So again, I simply fill in with how far is this, how far is that. That's what I'm looking for in those two boxes. I square it first, 25 plus 100. That gets me the square root of 125, which is about, get our calculator back out, 125 square root is 11.18. So from here to here is 7.07 units, from here to here is 11.18 units. So the total distance traveled by the ball in units is these two numbers added up. So I get 11.18 plus 7.07, 18.25 units. So 18.25 units is the total distance traveled by the ball, but again, it says 1 unit is equal to 9 feet. So to get feet, we're going to multiply that times 9. That's 45, carry the 4. That's 18 plus 4 is 22, carry the 2. 72 plus 2 is 74, carry the 7. 9 plus 7 is 16. 2 decimal places in the works, so 2 decimal places here. 164.25 to the nearest tenth of a foot is going to be 164.3 feet.
That's your answer, right?
And that'd be the total distance traveled by the ball.
Why don't we just keep 2.5?
0.25, well, I mean, it says nearest tenth, so I round to nearest tenth. So, and again, if I'm rounding my final answer to the nearest tenth, I try and get my work to 2 decimal places. It makes for a better accuracy on there. If I even want more, be even more accurate. Maybe it's actually 0.247 or something. Maybe it's 0.2 instead of 0.3, but that's close enough probably.